In this lecture, we're going to examine the way that networks work. When you first start looking at developing networks, it can all seem a little bit daunting, but it's basically all about the way that the network is physically set up and the communication protocols that are used to transfer information back and forward. Messages sent over the internet are sent using TCP/IP, or Transmission Control Program Internet Protocol. This is a standard way of sending data back and forward between computers connected on the internet. The data is sent in packages called datagrams, and the message in the datagram is called a payload. The most prolific IP address is a unique 4-number identifier, and you may have seen many of these before. They look like 204.53.216. The computer that you're currently working on will have its own IP address. This IP address identifies your computer uniquely in the whole world of the internet. The first 2 numbers of the IP address are the network IDs, and the second 2 numbers are the machine IDs. There are 2 different types of IP addresses. The first is a public IP address. If your computer has a public IP address, that means it can be seen from outside of your own home or office and directly connected to using its own unique address. The other type of IP address is a private IP address. With a private IP address, your computer has its IP address set, but it can't be seen outside of your office or home. It is connected to the internet through a router. The router has a public IP address that other people can access directly and see, but your computer has a private IP address, so it is protected from the outside and it cannot be connected to directly unless you want it to be. The way that clients and servers work is that a client is like a master machine that handles all of the messages that get sent back and forth. First of all, the server itself must have its own IP address. Each person wanting to connect to the server, the clients, must know what this IP address is. When you have a networked game, your game client knows what the IP address is because the developers have programmed the server's IP address in. So once the server has given all the clients an IP address, the clients can connect. They connect by making the server aware of their presence and telling the server about their own IP address. The server keeps a list of these IP addresses and can then send the messages on to all of the connected machines as required. So in this case, a client, once connected to the server, might decide to send a message to everybody else. This message goes via the server. The server processes the message and then passes it on to all of the connected clients. There are 2 types of servers. First of all, there's an authoritative server. The authoritative server maintains an entire game world. So the game environment and all of the objects in the game exist on the authoritative server's hardware and memory. The authoritative server runs all the physics and simulations, and the clients just act as a window into that world. Essentially, they are dumb terminals looking at a version of that world as they receive it from the server. These types of servers are best used for turn-based games. For real-time games, they suffer from something called lag. In this example here, you can see that the server is maintaining the entire game world. When a client performs some action with their player, that action command is sent to the server. The server then makes the action happen and then updates the game world and sends a view of that world out to all of the clients. As you can imagine, this could be quite slow based on your network speed. So if you wanted to move your player, for example, before you would see it move on your screen, the command has to go to the server and then come back to the client. The other type of server is a non-authoritative server. The non-authoritative server doesn't maintain a copy of the game world. It's merely there to send messages back and forward between all of the clients and to keep those coordinated. As you can see, each client has their own copy of the game world. This means that the client can move their own players and objects around in the game world immediately and suffer no lag. Information about the client's own game objects then gets sent to the server, and the server sends these messages to the other clients, and then their game world is updated. Other people's actions have a short lag because they're happening on the other client machines, which have to go via the server before they get to your game world. Now, we just spoke about lag. Lag, otherwise known as latency, is a slowing down of what's occurring in the game, so the actions. In an authoritative server, this shows the game world in the past because the clients are only ever getting a version of what's happening in the game world later and after it has happened. In a non-authoritative server, the client has control over their own game world. So the game states and their game objects do not suffer from any lag. It's only the other players and messages from the other players that are from the past. Latency can occur when you have bandwidth issues, network speed problems, if there are a number of players connected and the server is overloaded, and also based on the message load, so how many messages are being sent back and forth between the client and the server. There are three basic main types of network configuration. First, there's the LAN or local area network. Then you have a wide area network or a peer-to-peer network. A local area network connects computers in a local geographical space, and they are managed locally. If you have several computers set up in your house connected by a router, then you have a local area network in your house. They may also be connected with Wi-Fi. Office buildings have local area networks where there are servers and routers and other devices such as printers connected together in the same space. A wide area network extends over a large geographical distance. A WAN can connect multiple LANs. The internet itself is a wide area network. So when one office building is connected via the internet to another office building, this creates a wide area network. Peer-to-peer networking is when clients connect directly to each other and they then act as both client and server. You may have played mobile games using Bluetooth with another player. This would be a peer-to-peer connection. So you have a direct connection to all of the other clients without any server sitting in between to mediate. This has been a very quick overview of networking and the basics. We're now going to put those into practice using Unity to create networked games.